All right, let's have a look at 16C together. And what are we doing now? We're determining normal probabilities. And this all has to be pretty much done on your calculator, so make sure you've got that handy. All right, suppose that Z is a standard normal. We know all about the standard normal. It has a mean of 0 and a standard deviation of 1. So we'll write that down as our working. And we want to find the probability that Z is between -1 and 2.5. So if I draw a little picture of what this looks like, 0's here, -1, 2.5. So we can't use just our 68, 95, 99.7 like we did yesterday. We've got these other values, so we'll need to get our calculator to do it for us. So in your CAS, you press menu, and then 5 for distributions, 5 for normal distribution, and then 2, which is normal CDF. And you need to put these in. Our lower bound, 1. Our upper bound, 2.5. Our mean of 0, and our standard deviation of 1. And if you put that into your calculator, you should get 0.8351. Let's look at the next one. Probability Z is greater than 1. The mean here, 0. 1 is up here. So we're looking for this area here. So what do? We put in the same screen here. So we're still doing menu 552. Whoops. Except this time, what do? We do our lower is 1. Our upper bound, it goes forever, so we put infinity. And we still do mu of 0 and a sigma standard deviation of 1. And if you put that into your calculator, you get your answer, 0.1587. All you have to do is just change these two. All right, so sometimes we'll be given the probability and you have to find like what these type numbers are. So X is normally distributed, okay, with a mean of 100 and a standard deviation of 6. So I'm going to draw it. We want the probability that something is less than a particular value to be 0.95. So I'm thinking K is going to be probably up here. And what I want to find is what area is down here to find the probability. So how do I do that? Well, this time I go menu 553. And this is an inverse normal. So that's when it's going the other way. And what do we write in for our area? 0.95. Because there's 0.95 to the left, and it always has to be to the left. Might get a little song that comes to mind for that. Anyway, if you put that in, and then your mean is 100, standard deviation is 6, do that, and you get 109.869. So what does that mean? That means this value here is 109, and that sort of makes sense because we knew 100 was about there. So we've probably got it right. Okay, so when we do our normal curve, it can have some symmetry properties. So what that means is there's different ways of saying the same thing. So if we look at the probability that Z is less than A and the probability that Z is greater than A, they are equal. Less than negative A is the same area as Z is greater than A. I could also say, if I wanted to find the probability that Z is greater than A, this one here, that would be the same as 1 minus the probability that Z is less than A. Because this area and this area all add to give 1. What if I was looking for the area between negative A and A? This bit here. I could just say that's same as 1 minus 2 times the probability that Z is greater than A. Because the probability Z is greater than A is this. Times that by 2, and it's this. 1, take away those bits, leaves you with that. So there'll be all sorts of different combinations you can get with that, but just use your common sense, but that's the thinking around it. Okay, this to make sure you're watching. The first person to email me the sentence to the left, in honour of that, I'll bring you a chocolate next lesson, just because I want to know that you're watching it and you're watching it at the right time. So good luck to someone. All right, let's look at the last one. X is normally distributed with a mean of 100 and a standard deviation of 6. Find C1 and C2 such that the probability that X is between C1 and C2 is 0.95. All right, so if that's 0.95, what I do know is that there's 0.05 left, so there's 0.025 here, and there's 0.025 here. And my middle here is 100. So if I'm looking at the area to the left, for C1, I can press menu 553. This time the area is 0.025. The mean is 100, standard deviation is 6, and if you do that, that will tell us that C1 is 88.24. Now, you could do it again and use, this area of 0.975, or what you can do is use the symmetry properties. So I know that if this is 88.24, the difference between 100 and 88.24 is 11.76. So that means this one here must be 11.76 above if this is 11.76 below. So our C2 equals 111.76. And that's probably a quicker way of doing it and using that symmetry properties that we just talked about. So that's 9C. Please get onto it and try and finish those so we're ready for D next lesson.